of x equals x. Then we transform that function by multiplying our x by 1/4. We could find out what our original f of x coordinates are if we use some example x coordinates. So I'm going to choose -4, 0, and 4. If we plug these in for our f of x function, we're going to get back certain y values. So when I plug in -4 for my x value, so f of x is equal to -4, I get back that y is equal to -4. If I plug in 0 for my x, I get that my y, or my f of x, is equal to 0. And finally, if I plug in +4 for my x, I get that y, or f of x, is equal to 4. We can see these coordinate points on the blue function f of x, -4, -4, 0, 0, and 4, 4. So 0, 0, we have -4, -4, and we have +4, +4 right here. Now, if we wanted to figure out what our x and y coordinates are for our g of x function, we could write them out like so. We're going to evaluate f of x when 1/4 is being multiplied by our x value. We evaluate f of x when we're multiplying by 1/4. We evaluate our x's. So if we take this off to the side, we have f of x equals 1/4 times x. Well, we know that we originally chose -4 for our x. So 1/4 times -4 is going to give us -1. So we get -1. If we evaluate this function at 0, so f of x equals 1/4 times 0, we get back that f of x is equal to 0. And the last point, if we evaluate f of x at 4, so 1/4 times 4, we get back that y is equal to 1. All right, now we're going to piece it all together to get our new coordinate points for the transformed function and plot those on the graph to see the transformation that occurred. So our new coordinate points are going to start with the same x values. So -4 and then we'll move to -1. So this will be our x and our g of x coordinate points. So we have -4, -1. We have 0, 0, and we have 4, 1. So there's our 3 coordinate points for our new function, our transformed function. So we go to -4, -1, which would be right here. Then we find 0, 0, which is right here. That's shared with the original function. And then we have 4, 1. So we go to +4 and up 1. So we can see that when we multiply our x value by a fraction, here we are getting a transformation in which we have a horizontal stretch. And they show that here in the graph with the horizontal lines pulling and stretching at our blue function. So if we were to grab our blue function on the ends here, and we were to pull it horizontally, going in these directions, we're going to see it stretch and stretch and stretch to where it gets closer to our x-axis or closer to the purple function. And that is how you find a horizontal dilation.